Okay, so this is lecture 22, 1st of March, 2021. I have a dream that someday everybody joins on time and we don't have to interrupt. We're latecomers. All right. So let's see where we are. We've been talking about trusses, and we so far discussed the method of joints, right? So method of joints. So just to refresh your memories, I have printed out some of the pages of that online course that I have been referring to, which kind of summarizes where we are and where we are going. So we discussed what trusses are, and from the beginning, I said that first of all, we describe a truss being a structure that all members are two-force members, and then depending on what the objective is, if we want to find all member forces or only forces in a few members, we have two methods: method of joints that we use to find all member forces. And now we're going to introduce the method of sections. The only things that are important to remember are that being a member, a two-force member, every member, that you realize that when you're considering the equilibrium of a joint, the force that is acting on the joint, right, in whatever directions are on the corresponding member, you have a force opposite and equal to that force. And that's how we determine this two-force member is in tension or compression. So then we sort of set a rule of thumb: if the force coming towards the joint, therefore, in other words, this way, the force on the member would be that way, so the corresponding member is in compression. If the force is moving away from the joint, when you look at the equilibrium of a joint, the corresponding member is in tension. And of course, that course, which I'm not going to go over that here, if you'd like to take that online, goes through all these steps and explain these, which is what we have done in class as well. And so just in a nutshell, that's sort of a summary of what we did with method of joints. So in the method of joints, this kind of in a very briefly, what did we do? The major steps included was, step one, establish an XY coordinate. Step two, identify zero force members. Then you start, okay, by drawing free body diagram of a joint with minimum number of unknowns, solve for all those unknowns, and repeat the process, okay? So what is the method of section? Or in other words, when we are only asked to find a few member forces, well, how do we do that? Okay. Method of sections is, so this is, you want to, was the case that you want to find all member forces. This is the case when you want to find a few member forces. You want to prepare a truss, so you only want to know what are the forces in those members that you want to remove and repair. Okay. Procedure is slightly different. Step one is the same. draw X and Y coordinate. Step 2 is also the same. You do identify all zero force members because it's important. Maybe some of the members you've been asked to find are zero force members, so you don't have to go through the cumbersome practice of drawing all the free body diagram of all the joints, right? So it is step 3 now that we start seeing a difference. What do you do is this. You just cut the member, okay, that you have been asked that you want to find its force. So cut that member and minimum number of other members. So in such a way, okay, that truss is cut into two pieces, okay? Then what you do, you will consider the free body diagram, okay, of one of the two pieces, okay, that has the least number of unknowns, number of unknowns. You may ask, what happens if both sections have the same number of unknowns? Or, in that case, the one that is easier in geometry if both sections have same number of unknowns. Okay. So this may sound a little bit abstract. So let's apply this to the case, two example problems that I'm going to do here. So I will start with two, and hopefully on Wednesday we'll do more. Okay. So this is one example problem. Let's say you have a truss that looks like this. 1, 2, 3. Each of these members are 3 meters. Okay. This one is also 3 meters. This one is 2 meters. Okay. So you have a truss like this. Let me label that. These are all the joints. Okay. This is subjected to a 500 Newton force on this joint. Okay. And this, label this A, B, C, D, E, F, G. So this is the truss. Okay. And you want to find member force BE. So, and FE. So find forces in BE and FE. You start one by one. That is, for each of these, you need to consider the procedure that I just described. Okay? All right. So what is the step? XY coordinate. So you set that up. X, Y. 2, 0, force members. Okay. Do you see any zero force members in this truss? Let's pause a little bit. Anybody?
Point C.
Oh, sorry. I'm glad you said that because I forgot that I had actually load here. Sorry. So C is not the case because I have a load there. First, remember the criteria. Three forces. You look at a joint with three forces, two collinear. The third one is zero, right? Do you see anything here? Any joint that satisfies these conditions? Anybody?
Doesn't D have fewer than three forces? Joint D?
What is your name? Let's see. What is your name? You are, could you introduce yourself? Well, you just said joint D has two sections.
Oh,
Could
sorry. I think my internet cut out. Yeah. Doesn't joint D have fewer than three forces?
This is Nora?
Yeah.
Okay. You in fact, asked a question, which was an excellent question, and that's what I was, in fact, hoping somebody would raise. In the other section, nobody even thought of that. What Nora is saying, or the question that she's asking, well, this is the criteria that say three forces, right? But what happened if you have a joint where you have only two forces coming to that joint? What happens there? Can you, Nora, tell me, go to the next step and answering that question? What happens if you have only two?
Aren't they, if you only have two, aren't they like both zero force members?
Yeah. So I'm going to give you 7 bonus points, okay? Because that's a very important observation. And that reflects a very deep understanding of the concept of zero force member, what Nora stated. If you have a joint with only two forces, right? Let's say they're like this. What happens? If you consider this is X, this is Y. If you write summation of forces along Y equals to 0, this is the only force that has a component along Y. So that means this has to be 0. If that goes to 0, summation of forces along X equal to 0, right? Gives you this one equal to 0. You can look at it in another way. If you cannot, that would sort of resembles or uh, applies this concept. If you have two forces coming here, you can assume that you have a fictitious member like this. Doesn't exist, right? But if you have a fictitious member like this, these two are collinear, so this has to be 0. And if that is 0, there is no force here, that is 0 force. So this has to be 0. But anyway, whichever logic you use, you reach the conclusion that a joint with only two members and no external load, okay, means both members are zero force members. Remember that. This is a special and easier case of this general case. All right? So with that said, let's eliminate these two. Now that they are gone, do you see another zero force member here somewhere?
Point C.
Point C now. 2 collinear, this one has to be 0. Which means, basically, what this means, if this is gone, this force is only carried by this member. So this member, FCE, is carrying that load of 500 Newton. And since this is moving away from the joint, that member is in tension. Of course, you are not asked to find that member, but what it means, it is as if you have that force of 500 acting here, because these two don't exist. So as if this force is directly acting at that joint. Now we want to find these two member forces. So what did I say? You, let's say, start with BE. Starting with BE, you consider that member and cut that member and minimum number of other members, okay? So you can consider something like this. You can consider something like this. You can consider something like this. But each of these two cuts would cut more than, this one cuts 2, but this one what? 1, 2, 3, 4. This one, 1, 2, 3. So I will consider the cut that includes that member and as few as possible other members. Okay. Now, once you've done that, you have truss cut into 2 pieces. One is this piece, okay, right here, right? You have this, okay. So you have this piece, right? And then you have this one, which is this guy, this piece. So I'm assuming that, let's assume that the force is in this direction, this one in this direction. So in other words, you have, okay? So which one of these has fewer number of unknowns? 1, 2, 3, 4, 5, 6, 4 and 3, 7. Here, 1, 2, right? So I will take this free body diagram. Okay, so let's do that. So this is the F of BE. This is the F of FE that I want to find. That's what the problem is asking me to find. Okay, let's consider that free body diagram. 2 unknowns, 2 equations of equilibrium, summation of forces along X and Y. Of course, if you want, and I would actually use that approach in another problem, if you want, you can start by doing one at a time. That is, let's look at here. This was BF, okay? If I continue this, find a point O, in other words, find this distance, and take summation of moments about point O, this would go away. I have one unknown, but I will demonstrate that approach in another problem. For this one, let's take the easy route. 2 equations, 2 unknowns. The only thing we need is the slope of these, because I have to resolve these into their components, right? So let's do that. So what is the slope of this guy? Look here. This is 2, this is 3. So this is, okay, this is 3, this is 2. So this would be square root of 13. How about this one? This is 2, right? Okay. This is 2, right? So this one is, oh, I'm sorry, I completely did the drawing of this truss wrong. This problem was actually like this. Sorry about that. This is the problem. So forget about this. This was supposed to be like this. I don't know why I did that. Okay. So this is the original problem. Okay. That's what it was meant to be. Okay. So this is 3, this is 2, so this is 1. So the slope here is 1, 3 square root of 10. So now I can write summation of forces along x and y. Summation of forces along x is equal to 0. You have this one, which is 3 over square root 13 FBE. This one is negative 1 over square root 10 of FE, okay, is equal to 0. So this is this equation. Summation of forces along y is equal to 0. I have this one, which is negative 1 over square root 10 f of FE plus 500, okay, and this one, which is negative 2 over square root 13 f of BE is equal to 0, okay? And this is the other equation of equilibrium. If you solve for these, okay, you'll see that you get f of BE comes out from here to be positive. That is 600.9 kilonewton came out to be positive. So that means the assumed direction was correct. Force coming towards the joint. So this is in compression. Force of Fe from this equation comes out to be 602, again, positive. So force is moving away from the joint. So this is in tension. Okay? Any questions? No? All right. So let's move on. I'm going to do a problem which is from your book because I want to re-emphasize that concept that I mentioned last time, that if you have a structure that is symmetric, and this is a line of symmetry, geometrically this is symmetric. If the load acting on the structure is also symmetric with respect to that line of symmetry, members that are symmetric with respect to the line of symmetry carry the same load, okay? And also, these support structures, loads that they carry will be symmetric with respect to this line of symmetry. So I'm going to do this problem. What this problem is asking is this. First, let me draw the figure, okay? So this is the example, which is problem 647 from your book. And this is that problem. So bear with me. I'm going to draw this, and I'm not going to make a mistake that I did with the other problem, that I drew it wrong. Okay? So you go here. Okay. Okay. I did not do a very good job here. Okay. So now, okay. So this is the problem in the book. Okay, so this is the truss. So supposed to be symmetric. My drawing was not that great. So let me label all these joints. There's a roller at this support and a pin on this support. An external load is acting at this point, 16 kilonewton, 16 kilonewton. So let me label this A, B, C, D, E, F, G, H, I, J, K, L, M, N. All right. So this is, and let me give you all the um, dimensions here. You need that. So these are all 4 meters. Okay. And these spans are 3 meters each, the height. So 3 meters, 3 meters, 3 meters, 3 meters. The problem is asking you to find forces in member DF, EF, and EG. Okay. So let's start following those steps. Step 1, X, Y coordinates, right? Step 2, zero force, zero force members. Do you see any zero force members here? I don't, because I don't see a joint with 3 forces where 2 of them are collinear. Every joint I see here either has more than 3 forces or, for instance, here, they're not collinear. So that's gone. Then consider the member that you want to find its force. Let's say member FD, which is the first one. Cut this member in such a way that by cutting it, you have cut the truss into 2 pieces, but that cut would include as minimum number of members as possible. So if I look at this, I can cut this like this, 1, 2, 3 members, cut it like this, 1, 2, 3. I can cut it like this, 1, 2, 3, 4, 5, and so on. You see that either this one or this cut would be the best. So I will consider this cut. It includes the member that I want to find its force and 2 other members. And given the geometry of this piece, although the number of unknowns for each section are the same, this one is easier to deal with because of its geometry. However, before I go a step further, this truss is kind of unique in the way it is loaded. Why is it? Because if you look at the support forces here, you say that, okay, I have 2 unknowns here and 1 unknown here, right? But look, if you take summation of moments about point A, all these 3 and this force pass through that, so this comes out to be 0 because there's no other force acting on the truss. And because of this symmetry, this would be 0. And of course, summation of forces along S gives you this 0. So there are no support forces. This truss is only held in place by these two forces that are pulling these two nodes together. So if I draw the free body diagram of that piece, it looks like this. Okay? I have basically this. This is the cut. Okay? This is that cut 1, 1. This is 1, 1. Okay? So this is A, B, C, D. This is the force of that member that I want to find. Force DF. Okay? So this is force of DE, and this is the force of, let's say, consider this one this way, force of CE. I want to find this guy. All right? Remember, always when you are asked to find one unknown and you have three unknowns, obviously you try to minimize your efforts, right? That means you get rid of the other two unknowns. How do you do that? The concept I've emphasized and emphasized. If you have three unknowns and you want to find one of them, look and see if you find a point that those two unknowns intersect. And here is the case. These two unknowns intersect at point E, right? And by the way, the slope here is 3, 4, 5. So if I resolve this into its components, which I need, this would be 3/5 of F dF. This is 4/5 F dF. So if I take summation of moments about point E is equal to 0, what happens? I have only this force and this force. So this would generate a negative moment, negative 3/5 of F dF. This one generate a positive. What is this distance? Is given is 6, is equal to 0. Okay? Or 3/5 times this distance, okay, which was what? 4 plus this times that distance. Okay? If you solve for this, you find F of dF comes out to be positive 40 kilonewton. So the assumed direction is right. Force moving away from the joint, that means this is in tension. Any questions? Next one. You want to find, so this was force dF. Problem then is asking you to find member force FE. Okay, so let's do FE. Again, you cut that force or that member and as few as possible other members. So this is the full cut that I would perform because I've got 1, 2, 3. You could have cut it like this, 1, 2, 3, 4, 5. This is the best. So again, look at the two pieces. Let's draw that free body diagram. I have this, okay? Okay, I've cut, this is what I've cut. So this is that member force, okay, dF that you found, and that was 40 kilonewton. This is 16 kilonewton. This is A, B, C, D, E, okay? and you want to find FE, which is this one. This is the force of FE. And then let's say this one is a force of EG. So this is the force that I want to find. Okay. Again, I'm lazy. I don't want to go through solving for more unknowns that I need. I only want to find this one. So how do I get rid of this unknown? By writing the right moment equation. Easy, right? If I take summation of moments about point A is equal to 0, this force goes through that. This is known. This is the unknown. So let me again resolve this. This is 3, 4, 5. So this is 24. This is 32. Okay, those are the forces I have. So take summation of moments about A. This goes through that. This one would generate a moment in positive. So that will be F of FE times this distance, which is 8. Okay. Any question? Do you see that? Then you have this one, which is negative 32 times this distance, which is 6. And this one, which is positive. So 24 times this distance, which is 4, equal to 0. And if you solve that for that, you see that force of Fe comes out to be, okay, 12 kilonewton, and turns out to be positive. That means force moving away from the joint. So this is in tension. Any questions? Any question? Let me pause. Okay. The last one, you want to find the force of EG. Okay. So again, this is this is EG. You cut this and as few as possible other members. You can consider this cut, or you can consider this cut. Okay. I will consider this one because not only you've got only same number, but you already found these two. So you have the value for these. So that's what I would do. But let's consider this cut, right? Okay, which is the same. I have it right here. And I want to find F of FG. Okay. All right. So let me redraw that, and I have reasons for doing that. So let me redraw that. Okay. I have this. So this is that force, which is 40 kilonewton. This is this force, which we found is 12 kilonewton. And this is the force that I want to find, F of EG. And this is 16 kilonewton. Okay. This is the force of EG. Again, I'm lazy. I just want to find that force and don't worry about anything else, right? And the easiest way possible. Obviously, you can say that, okay, I can write summation of forces along X or Y and find that. But I want to do it even an easier way, if possible. First of all, you need to resolve this into its components, right? So this is 4/5 of FEG. This one is 3/5 of FEG. What do I do? if I continue this, they cut here at point F. So what I will do, instead of writing summation of forces along X or Y, which has more terms in it, I would take summation of moments about F is equal to 0. And the reason is I get rid of one component here, right? If I had written summation of forces along Y or X, I had to deal with more terms. So if I take summation of moments here, I have only this, which is negative F of E G times 3, right? And then this, which is positive, plus 16 times this distance, which is 9, equal to 0. That will give me F of EG. That comes out to be 60 kilonewton positive. Force is coming towards the joint, so this member is in compression. You could have, if you wanted to, written also summation of, let's say, forces along X is equal to 0. But look how many terms you have. You have here negative 4/5 FEG plus 16, right? Plus this one, which is plus 32 is equal to 0. So you have 3 terms, whereas here on you have 2 terms. Either way will give you the same results. Any questions?
Why did you use FEG times 3 when you like? Why isn't that one of the components of?
Oh, see, I'm glad you noticed it. This is not FEG. This is 4/5 of FEG. I'm glad you caught me. Thank you. Any other questions? And it is only Monday, right? I'm not supposed to make mistakes. All right. No other questions? We have only 3-4 minutes, and I only could do these 2 problems in the other section. So for that reason, and to be fair with the other section, I'm just going to stop here and answer any questions.